Exercise 7.11, question 30. Uh, I is equal to integration minus pi by 2 to pi by 2 sine raised to 7x dx. Right. Here you can see that my f of x is sine raised to 7x. So if I take f of minus x, then it will be sine minus x raised to 7. The sine is odd function, so I can write it like this, and even as the power is odd, I will get minus sine raised to 7x, which is minus f of x. So you can see that f of minus x, I got it as minus f of x. Therefore, according to property 8, I can write this as 0. The integration of this is 0. If the function is odd function, then the integration minus a to a f of x dx is 0 using property 8. You should write like property 8. Right. Question 14. I is equal to integration 0 to 2 pi cos raised to phi x dx. You can see that here f of x is cos raised to phi x. If I take f of minus x, then it will be cos minus x raised to phi. As cos is even function, I can write this as cos raised to phi x, which is f of x. Here you can see that minus f of x is equal to f of x. So by property 8, I can write this no, we will not take it as minus x, sorry, but we will go for property 7 over here, not property 8. So I will replace this f of x by a minus x, that is 2 pi minus x. I will replace this by 2 pi minus x. So cos 2 pi minus x whole raised to pi. As you can see that 2 pi minus will give me fourth quadrant, and in fourth quadrant cos is positive. So cos raised to phi x, that is f of x. As you can see that f of 2 pi minus x is uh, f of x only. So by property 7, I can write 0 to 2 pi cos raised to phi x dx as 2 integration 0 to pi cos raised to phi x dx. Right. Now if I want to integrate this, then I will break this cos raised to phi x as cos raised to 4x into cos x dx. Right. Converting this into sine, I can write this as cos square x whole square. And this cos square x can be written as 1 minus sine square x. Now if I assume cos x as t minus, sorry, I will assume sin x as t. Sin x as t, then I will get cos x dx as dt. So I can replace this value 1 minus t square whole square dt. Right, expanding will give me 1 minus 2t square plus t raised to 4 dt. Will integrate, I will get t minus is 2 into t cubed by 3 plus t raised to uh, 5 by 5. Right. Now we have two options available over here. Either I can change the limit or will put back the value of t as sin x only. So will not change the limit, but will keep the value of t as sin x only. 0 to 5. Right. And this is 0 to pi, not 6. This is 0 to pi. Right. Okay. Let's rub this column 1 and we'll continue. Right. So here first we'll keep the value of x as pi, sin pi minus 2 sin cube pi by 3 plus sin raised to 5 pi by 5 minus bracket, and now we'll keep the value of x as 0. But I know that sin pi is also 0 and sin 0 is also 0. So finally my answer will be 0. Question 15. I is equal to integration 0 to pi by 2 sin x minus cos x dx upon 1 plus sin x cos x. Right. So using property 5, I can replace this x by a minus x. That is over here, a is pi by 2. Leaving this as equation 1. Now I will replace x by pi by 2 minus x. Right. Let me just put up this first and then we continue. So this I can be written as 0 to pi by 2 cos x minus sin x dx upon 1 plus cos x sin x. If I take minus common outside from numerator, then I will have cos x sin x minus cos x dx. And as the multiplication is commutative, I can write it as sin x cos x. But from 1, I can see that this is I. from equation 1. So 2i is equal to 0. I is 0. Therefore, the value of I is 0. Now complete this as I required more space in question 16. So first complete this, then we move on to 16th question. Question 16. I is equal to integration 0 to pi log 1 plus cos x dx. Give this as 1, we will use it. Using property pi, I can replace this x by pi minus x. And you know that pi minus is going in second quadrant where my cos is negative. So I can write it as minus 1 minus cos x dx. Give this as adding 1 and 2 will give me 2i is equal to 0 to pi log 1 plus cos x plus log 1 minus cos x whole dx. I'm just taking integration common as both of them is having the same limits. Now applying property of log, taking common log and they are in addition, so they will multiply dx. Right. Now I know that a square minus b, a plus b minus b is a square minus b square. And applying identity over here, this is 2i. I will have sine square x dx, and again applying the property of log, I will have 2 log sine x dx. Taking 2 common outside, I will have the value of I as 0 to pi log sine x dx. Give this as 3, we will require afterwards. Now, here f of x is log sine x. So if I replace this x by pi minus x, then I will get back the same value as pi minus is second quadrant where sine is positive. So you can see that by property 7, if f of 2a minus x is same as f of x, then I can write this same integration as 202 pi by 2 log sin x dx. Give this as 4. Now, by property pi, I can replace this log sin as pi by 2 minus x dx. So this will be log cos x dx. Give this as pi. Adding equation 4 and equation 5 again, I will get 2i is equal to 2 integration 0 to pi log sin x plus log cos x dx. Taking common log, I will have log sin x cos x dx. You can see that this question is getting lengthier, but it's okay. To make this as sin 2x, I will multiply 2 in numerator and in denominator. Okay, so we'll continue over here. I can write this as log sine 2x by 2 dx, and again applying the property of log, I can write this as log sine 2x dx and giving individual integration to both of them minus log 2. Here I will assume uh, see, here we did a mistake. The integration limit was going 0 to pi by 2 pi by 2. I have changed it over here 0 to pi. So you can see that the limit will be 0 to pi by 2 only. Here I did mistake. I just took the 0 to pi. It was 0 to pi by 2. You can see that the limit is going same 0 to pi by 2. So here also I should keep it pi by 2 only. Now if I assume 2x as t, 2 dx will be dt and dx will be dt by 2. Limits will also get changed. If x is 0, then t is 0. If x is pi by 2, t will be pi. So I can replace this as 0 to pi log sine t dt by 2. Here 2 will come outside. Here also pi by 2. And this will be just dx. Right. So this 1 by 2 will come outside. And again, I will replace this. I can replace this t as any variable. You know that this is the property of integration, that I can write this variable t as variable p, variable s. So why don't we write this variable as x only? See, if I write x here pi by 2 minus 0. If I write this as x, then comparing with the equation 3, I can replace this as I. 0 to pi log sin x dx. You can see that equation 3 is telling us that this is I. Now, if this goes over here, I minus 1 by 2 I is equal to minus pi by 2 log 2. Right, and I know that 1 minus 1 by 2 is 1 by 2 I. And my these two and these two will get cancelled out. And finally, the value of I that I will get is minus pi log 2. Right. This is your final answer.